Hello everybody, welcome to my YouTube channel, and we are on the stage to discuss the exercise of ISLR book of chapter 2, and we are following our lectures from ISLR book mostly up to this time, and I try to add some content which is useful, which is necessary at step by step to study that and to understand what we are studying. So but most of the content as I told in the first of video also, we are following the ISLR book. So almost we finished the chapter 2 theory. Now it's time to discuss the question. It's time to check the knowledge what we have understood from this video series. So let's start from question number 1. It is talking about indicate whether we would generally expect the performance of flexible statistical learning method to be better or worse than inflexible method. To give the answer of this question, first we should understand what is the flexible method and the inflexible method. Generally, flexible method we use when we have a complex data set, when we have the large amount of a data set, and when we have the high bias model. In that case, we use the flexible method to reduce its biasness, whereas inflexible methods are the more interpretable we use when we have the to study the relationship between the response and the predictors and to make some interpretation from that. So inflexible methods are generally more interpretable because these are very simple methods like linear regression. Okay, so these are the inflexible method. Okay, now come to the question number 1. It is telling the sample size n, the sample size is extremely large and predictors are very small. When we have the large sample size, we can have a chances of error due to the variance. Okay, due to the variance. So to reduce this error, we should use here flexible methods, because flexible method can capture the complex relationship. It can capture the complex relationship if the data set have between the predictor and the response. Then here the number of predictors is small, so we no need to worry about the computational cost. So we can use the flexible method compared to the inflexible method. So in this case, the flexible method work better compared to the inflexible method. Now come to the second case. Now we have the extremely large predictors and we have the very small data set. In this case, if you use the flexible methods, okay, if you use the flexible methods, then it is very easy. They can easily overfit to data. Why? Because I have the very less sample size, I have very less amount of a data. Okay, so in that what will happen, my model try to find some pattern which can exist in this data. But once at the testing phase, once I will test my model, it is not easy for that model to find same pattern in the testing data set. So in that what will happen, I will have a high variance because I will have the training error very high but testing error may be very less. So in this case, when I have a less amount of a data, I should go first for the inflexible method. Now here predictors are more. Here the predictors are more. So what will happen if I use the flexible method? The computational cost is very high. But for this, if I use inflexible method, maybe it work well because I have a less amount of a data. I have a more predictor, so maybe it will work well. So in this case, inflexible method work well compared to the flexible method. So this is the explanation of question second. I hope you understand. Now, the relationship between the predictor and the response is highly non-linear. So once we know it is a non-linear, we no need to think about inflexible method. We should try to go for the flexible method because the flexible methods have an ability to capture the complex or the non-linear relationship compared to the inflexible method. Because if you use the here inflexible method, say if I use the linear regression here, and linear regression have a basic assumption that data is linearly separable, but I know the relationship is a non-linear, so why I will go for the inflexible method? I will go here for the flexible method. So here the flexible method work well compared to the inflexible method. Here the inflexible method and here the flexible method. Now come to the part D. The variance of error term sigma square is equal to variance of epsilon is extremely high. If you remember, we break the error in the reducible plus irreducible error, and this irreducible error we define with the variance of epsilon. And we comment many time in our video that irreducible error is the error which we can't reduce. It is God gifted error, okay, but reducible error is break to the bias and variance, and we study very well the trade-off between the bias and the variance and how to do trade-off. That all already we have discussed. But now the question is, variance is very high, that means irreducible is very high. So in this case, which method you will go? You will go for the flexible or you will go for the inflexible? But what I will say here, the information we do not have enough information to decide. So in this case, I will start always with the inflexible method to save my computational cost, or it is maybe I want to try and I want to see how my inflexible method working here. If it is working very good, so I will never go for the flexible method. So the answer of this question, I will say I will start with inflexible method. And I am starting for the inflexible method here, because at the initial stage I try to avoid the overfitting of a model. Okay, so I will try with the inflexible method and see how it is working. So the final answer, the inflexible method work better compared to the flexible method. But again I will say I do not have enough information to comment on if I have a more irreducible error, because this is the error. Any kind of any algorithm if I use, then also I am not able to reduce it. So I hope the answer of this question is clear. The second question is testing the knowledge about the classification or the regression, and we need to indicate we are more interested in inference or the prediction. So here we should understand the basic terminology, that what we have discussed already in our video. What is the classification, what is the regression, what is the inference, and what is the prediction. Already I recorded the video for this. And okay, we need to provide the n and p value, that is the number of sample size, and p is the number of a predictor as well. So let's start the question number 1. We collect a set of data on the top of the 500 firms, okay, in the US. For each firm we record the profit, number of employees, industry, and the CEO salary. Okay, so we are interested in understanding which factor affect the CEO salary. Now come to the point here. CEO salary is our response. Okay, this is our response. Now profit, number of employee, industry are our predictors. So I can say p is equal to 3 and n is equal to 500 I have here. Okay, now as I say, CEO salary is a response variable. So how is our response variable is a continuous here, because salary can't be discrete. Salary is a continuous variable. So once this salary is a continuous, I directly will comment this problem belong to the regression problem. Okay, this problem belong to the regression problem. And we are interested in understanding. We are not going to predict the next CEO salary based on these factors. We are interested to understand what is the relationship between these predictors and the CEO salary. So that means it is clearly indicate this is the inference problem. Okay, now move to question number 2. We are considering launching a new product. What we are doing, we are launching a new product. When you are reading this kind of a question, say in interview or in a written exam, you have to do the underline to understand. It is one of the best way to understand what you are getting from the question. So we are launching a new product, okay, and wish to know whether it will be a success or failure. Okay, I get my this key concept, the success and the failure. Okay, so this is what my response variable, either I will get the success or the failure. Okay, so this what is a kind of this variable? It is a discrete, means I can count it. Okay, I can count it, and basically it is a binary variable. That means it is a case of the binary classification, means it is a case of binary classification, or I can say it is a problem of a classification in place of a regression. So just reading the two lines, I can give the answer. Now we collect data on the 20 similar products, n is equal to 20. Another answer will also I give. Now they are collecting the data on similar product that were previously launched. Okay, for each product we have recorded whether it was success or failure, price charge for the product. Okay, this one can be the one variable, price or price charge of the product, marketing budget, competition price, and 10 other variable. Okay, so this is the predictor 1, 2, 3, and 13 is the predictor here. 13 is a p value here. Okay, and for each product we have recorded whether it was successful or failure. So this is our target. This is our the target value. What I give the answer, it is already the classification problem. Now I want to comment, it is an inference or it is a prediction. It is clearly, we can see it is a prediction problem, because we are launching a product and similar to that product we already have the 20 product in our list. So what we are going to do, we are going to estimate the value of the upcoming product which not yet launch. Okay, so this is the prediction problem. Okay, we are interested in predicting the percentage change when I know we are going to predict it. So it is a prediction problem. It is clearly in the first line, and we are going to do percentage change. That is it is a continuous value. Then it is a problem of the regression. Then you can give the answer here for the N and P. Okay, moving to the another question. Question number 3 is telling provide a sketch of a typical bias, variance, training error, test error, or the irreducible error curve on a single plot as we go from the less flexible statistical learning method towards the more flexible approach. Okay, so the x, already I keep it this picture here. The x-axis is this is the flexibility, and this is the error in the y-axis. Okay, and there should be 5 curves. Make sure the level of each one. Okay, as you increase the flexibility, your variance will increase, your bias will decrease. As you decrease the flexibility, your bias is increase and your variance is decrease. That's what we already have studied in our video. Now explain why each of the 5 curve has the shape displayed in the part A. Okay, I can show. Okay, so this dotted line is the variance of epsilon. This is the irreducible error. Okay, now what I'm saying you, if I increase the flexibility of my model, the training error is very high at the starting, but then it will be start decreasing. Okay, once it will start decreasing. Okay, so let's take one by one term and explain after. So this irreducible error is clear. Now comes to the biasness. So biasness is that it is an inability of a model to capture the true relationship between the predictor and the response. So if I use the less flexible method, if I use the inflexible method, I will get my high bias. To reduce the high biasness, I will use the flexible method. So as I go toward the flexibility, the biasness will reduce. Now if I talk about the variance, if I use the inflexible method, my variance is very low, but if I increase the flexibility, my variance is decrease. Now if I talk about the training error, when I have the less flexible method, my training error is very high, but as I increase the training error goes to very down, and test error if goes to very high. So in this case the model is start overfitting. Okay, now this test error is what, in the inflexible method it is very high, then it is decreased, then it's come to the minimum here, then it will be increase. So my always interest to choose this optimum, to choose this minimum error. So this is the test error. Already we have explained this terms in more depth in our video. So if you have any doubt, you can just go and watch the videos. That makes more sense compared to this short introduction here. Okay, without wasting the time, the fourth question is for you, where you need to give the 3 real life application for the classification. And for the first question you have to give the classification, and here the regression, and here the cluster analysis. Let's tackle first the cluster analysis. The first things come in my mind is the recommendation system, because in the recommendation system I'm doing, I'm collecting the similar profile of the people who is watching the romantic movie and who is watching the thriller movie. That kind of a data I'm collecting, I'm doing one cluster, and so that it is an application of the cluster analysis. You can think about two more application: the regression, the house price, one of the most easiest problem. Then any continuous variable, if you want to think, that will kind of a regression, and discrete variable, if you think, that is kind of the classification problem. Say airline satisfaction, people are satisfied or neutral or dissatisfied, this is a classification problem. So this fourth question is completely for you to think. You can make any example. If you have any doubt, if you have some example like you can't classify it as a classification, regression or cluster, then just post me in the comment section, so people and I can give a reply there. That will be very helpful for others also. Moving to the next question here, question number 5. What are the advantages and disadvantages of very flexible approach for regression or classification? Okay, no need to further go for this question. First, let me discuss what are the advantages and the disadvantages of a flexible method. First, if I discuss the advantages here. So flexibility, if I have very flexible method, it can capture the complex relationship, work for the nonlinear data. Why it can capture the complex relationship and the nonlinear data? Because if I have a flexibility, then for the function f, it can generate many functional form of f, because we have a flexibility to generate different kind of a functional form, as well as it does not making any assumption of a underlying data. That means flexible methods are completely non-parametric methods. Then one of the most important is it help us to reduce the biasness of a model. Okay, now this is the advantage. Now what is the disadvantage? Of flexible methods? If you increase the flexibility, interpretability decrease. If you increase the flexibility, okay, then if you increase too much flexibility, then it can easily overfit to the data. Because if you start increasing flexibility, it can capture some pattern which have a noise. It can capture the pattern which include the outliers in the dataset, and which cannot be a case in the testing phase. So our training error can be very high and test error can be low if we increase too much flexibility. So we need to make sure, as while increasing the flexibility, we need to increase the flexibility up to a certain limit, where we can achieve the optimum error, where we can achieve the minimum error. For flexibility method, as the same explanation, it can go for the suppose we have the small data set, same explanation can go. You can have the training error is very high, but testing error is not, it can't be very high. It can be and cannot be. So that is also the case. So when we have the large data set, then only we can go for the flexible approach. Okay, so under what circumstances might a more flexible approach be preferred to the less flexible approach? Already I give an answer. When you have the large data set, when we have the high bias model, we can use the flexible method. And when might a less flexible approach is to be preferred? When your interest is interpretability, when your predictors are very high, when your n is very low. So these all things we already have discussed in question number 1. Okay, I hope you understand question number 5, but let me know if you have any doubts. Moving to the question number 6, what is the difference between the parametric and the non-parametric statistical learning approach. So in the parametric is what you make the assumption about the functional form of f. The function which you are going to estimate, you already make an assumption. You start with an assumption. Okay, I'm going to solve the regression problem. My function will be the linear regression problem. My function form is a linear form. So once already you have decided your functional form, then your problem become very easy. But what will happen is this is will not be always the case in the real world, that what the assumption you make while applying the parametric methods, that the same shape you will get for the function you are estimating. It is not always the case. So, but whereas non-parametric methods does not make any assumption. Whatever the function you're going to estimate, it seriously does not make any assumption about that functional form, about that data. It's just try different kind of a function form. Okay, so what are the advantages of parametric approach to the regression or the classification? So the one of the advantage is that once you know that your parametric method is a linear form, so you no need to estimate the full function. You just what you need to do, you need to beta naught plus x1 beta 1 up to xp beta p. You need to measure this coefficient, that is a 1 plus p coefficient you need to measure in place of the fully estimate the function. Once you know this coefficient, you can put the value and you can get the y value. So this can be the one advantage. What are its disadvantages? This linear form may be not exactly the linear form in the real world of what the function you are going to be estimate. So this is the important question here, and we can expect this question in some interview as well. Now question number 7 is goes to our KNN algorithm, which we already have discussed in our last video. If you did not watch the video, please go and watch the video. So already I read the question, so just read it again. Suppose we wish to use this data to make a prediction for y when x1 x2 x3 equal to 0 using the k nearest neighborhood. So question number A part, compute the equivalent distance between each observation and the test point x1 x2 x3 is 0 0 0. So I have 0 3 0 and I have 0 comma 0 comma 0. So I just calculate the equivalent distance. It is the 0 square plus 3 square plus 0 square. This is the 3. Okay, then 2 0 0 and 0 comma 0 comma 0. Firstly calculate it. Again it is a 4 and it is again 2. I'm fastly calculating here 0 1 comma 3. Okay, once I calculated the distances, equivalent distances. So what is our prediction when k is equal to 1? So I have the one nearest neighborhood. So I need to choose the minimum distance. Minimum distance is the 1.4. Yes, yes. So 1.4 is the minimum distance and my value will be the green for the first case. Green. Okay, when k is equal to 3, so I need to see the nearest distance is 1.4 1.7 and 2. So for this 2 is red, then 1.7 is 6 is again red, 1.4 it should be green, 1.4 is the fifth value, yeah, it should be green. Now I do the majority vote and I can say it is a red. Okay, easy. So this is how our KNN work. Now if the base decision boundary in this problem is highly nonlinear, then now our decision boundary in KNN is highly nonlinear. Okay, then would we expect the best value for k to be large or small? Now I discussed already, if k is small, it will overfit. If k is very large, it will underfit. Okay, now the decision boundary is non-linear. When we have the decision boundary is non-linear, that means we should use the flexible method to make the decision boundary more flexible. I will choose k value is a small, but not too much small, but small, not in place of the large. So that is the answer of this question. I hope you understand the answer of this question. And if you have any doubt regarding any question, these are very simple exercise. In the next video we will discuss about its practical exercise in Python in place of R. So if you understand anything, and if you like this video effort, then please like, share and subscribe to my YouTube channel, and we'll meet you soon in the next video. Up to that, thank you, take care, and bye bye.